Hello, thank you for joining me, and thank you, John, for sending me this model. John sent me this model, and he wanted to get some advice on how to finish off a thread on this model. Now, if I understand him correctly, what he wanted to do, or what he wants to do, is take the thread that you see here and extend that and transition that into the cylindrical base of that part that goes into the oil tank. So this looks like an oil cap, perhaps to a John Deere tractor, judging from its color. Very well detailed model. I'm pretty impressed with that. There's a lot of details into it that you would normally not see. And just to make this model a little bit more clear, I'm going to go ahead and change my display state and put in shaded with edges. So now you can see that a little bit better. Cool model. I really like that. So John had suggested, in regard to doing that transition of the thread into the base, and what we're trying to do here is try to emulate what we see in this photograph. We're going to take the very end of the thread here and transition it, as I mentioned, into the cylindrical base and try to emulate the way it looks here. John had mentioned maybe using a loft. And a loft would be straightforward enough. What we would need with a loft would be to have two different profiles. One of them could be this triangular profile here, which is easy enough to pick up. But the other end of the profile we could probably use a point and just transition it down there. The problem with the point is we'd have to find some sort of, probably in a 3D sketch, some sort of place on this space in order to put that in here. We'd have to know what the pitch is going to be and probably put it, make some sort of reference to the helix that's already there. We also need some guide curves in regard to the loft too. The guide curve on this cylindrical surface would be pretty straightforward, but what would be a little bit more complicated would be kind of a tangential extension of the helix that helps define the thread as you see it here, and taper that down to where that point is. So there might be kind of a weird little plane that we'd have to put in there in order to find where that guide curve is going to go. What would be a simpler way, since we've already done a sweep using a helix feature in here? Let's just put another feature in here, another helix in here, because helix come with an added option here that allow you to taper that helix. And what we're going to do is we're going to take that helix with the same parameters that define the helix, in the thread just above this feature, and we're going to use those parameters and put a taper to it. So what it's going to do is it's going to transition very smoothly from the existing thread down to the base down here. One problem with that is, if we were to do it right now and put that at the very bottom of the feature manager tree, is it would interfere with some of the details that we see on the inside of our model. And more specifically, what it's going to do is it's going to begin to violate the inside of this. So when we do that sweep feature, it's going to taper down to nothing down here, but it's also going to stick out a little bit inside of this hole that we have inside of the gas cap, inside of the oil cap. So we're going to try to avoid that. And one way to avoid that is to take our rollback bar and take that feature. We'll do the rollback bar here in a minute, but we're going to take both of our threads and we're going to move them up our feature manager design tree, so it's just below this boss here, but just before we put in that hole in there. So if we roll that back to just on top of the threaded boss recess, and that defines that hole, this is where we want to put it. So we're going to take our two different threads, the one we already have existing and a new one we're going to put in here. We're going to put it right in that position in the feature manager design tree, so when we actually do this feature in here, the threaded boss recess, that it cuts not only the hole in the bottom of our oil cap, but also cuts the sweep portion of that tapered thread that we're going to put in. So I think it'll be appropriate. So we're going to have two more videos after this one. The first video is going to be to correct some mistakes. There's some, not necessarily mistakes that John did in his model, but some references that didn't get really picked up when this model was rebuilt. We're going to go ahead and correct those, because I know when we move this feature up the feature manager design tree, some errors occur. What I like to do is I like to demonstrate what I call the red dot editing feature that SolidWorks put into their program here about 5 or 6 years ago. What it does with the end of dimensions or maybe sketch relations that no longer have that reference in there is what it does is when you click on that, and click on the end of that dimension and click on that reference, it'll give you a red dot. You have the ability to take that red dot and move it to a piece of geometry that exists in your model so far, and allows you to redefine that without having to delete the relation and go ahead and put it back in. It's a little bit quicker to do. Sometimes it's tricky. So I'm going to go ahead and show you how to do that, and then the second video that follows this, number 3 in the series, I'm going to show you how to put in that tapered helix, and that will produce that tapered thread. So we will see you soon.